Alright, so our first video for this year is a review over, I would say, a mixture of Algebra 1 and Algebra 2. It is just some ideas to be familiar with, things that we'll be looking at quite a bit as we go through both the trig and the calc sections of this year. We're breaking up today's notes into two parts. The first part are 7 different types of equations that you need to be familiar with. First one that we are looking at is an identity. An identity is an equation that's true for every real number in the domain. You may remember from algebra that the domain are the numbers that can be plugged in to a function. And as you look at the example of an identity, you'll notice that really what it is just a rewrite of the same idea, or of an equal idea. In this example here, you can see that x squared plus 6x plus 5 is exactly the same thing as x plus 5 quantity times x plus 1 quantity. So that's an identity. Second type of equation that you should be familiar with is called a conditional equation. And this is really the kind of equation that you are probably most familiar with as you go through algebra, because these are the kind of equations that we typically try to solve for x. Because in a conditional equation, that's an equation that is true only some of the time, or it could be true all the time, or it can also be true never. It's possible that you have an equation that can't be solved. We call that no solution usually. So an example of a conditional equation is 4x minus 5 equals 7. Obviously, if we would solve that, adding 5 to both sides and dividing by 4, we would get x equals 3. So this equation is only true when x equals 3. The third type of equation is one that I'm sure you're familiar with. It's very much the basis of much of Algebra 1, and that's a linear equation. Remember, a linear equation is an equation that follows the form ax plus b equals 0. It's called a linear equation because if we graph it, the graph of a linear equation is always a line. And the thing that I want you to remember most about linear equations is you have to remember that it's a linear equation because the variable, in this case x, is always to the first power. Fourth type of equation that I'm sure you're already familiar with are quadratic equations. Quadratic equations, remember, are the form ax squared plus bx plus c equals 0. And again, the thing that you really want to make sure you remember is that any kind of quadratic equation is always going to have a power of 2 in it. And if you graph these, they're typically a parabola, something along those lines. We'll talk more about those later on. We'll quickly go through these last couple of different kinds of equations. We don't see these as often, although you will see them a little bit in this class. Polynomial equations. A polynomial equation is just any equation that features x to some degree. Linear equations, quadratic equations, cube equations, those are all types of polynomial equations. So anything that's got some x to the third or x squared or x to the fourth and other kinds of coefficients in the equation, that's a polynomial equation. So not a real important term to remember. Next one is a radical equation. Shouldn't be trying to figure out that a radical equation is going to have a radical in it. Probably what's more important is that you remember that a radical means the square root. You'll hear me use that term often through this class. The word radical. Just remember that radicals just simply mean that you have a square root in the problem. You gotta remember that anytime you introduce the radical into a problem, you're going to have both a positive and a negative solution to that. We'll look at this idea again a little bit later as I look at some of the example problems for you to solve. Just something to keep in mind. And last but not least, with our 7 different types of equations, our absolute value equations. And again, just like with radical equations, not too hard to figure out. Absolute value equations are those that have absolute value signs in them. And again, the important thing to remember here is when you're solving an absolute value equation, you must split it into 2 parts in order to solve it. The reason you do that is to be able to solve for the positive value and then the negative value, because remember, the positive and negative, when you put them in the absolute value symbols, will give you the same answer. So it should be intuitive to you that there will be 2 answers to most absolute value problems. And again, I'll show you how to do this method as I look at some example problems here in just a second. So those are your 7 types of equations that you should be familiar with as you leave Algebra 2 and you start trig and calc. So for the remainder of this video, I'm going to go through, I believe, 9 different kinds of example problems. If you can do these 9 problems, or if you have a pretty good idea about them, you should feel pretty good about the work that we'll be doing in class. At any point, stop the video, work on trying to solve it for yourself first, and then you can always resume it and see if you did it correctly. You have some fractions in this first problem. Remember, in fraction problems, you have to find a common denominator. Common denominator for 2 and 3 are 6, obviously. Remember that whatever you multiply the bottom of the fraction by, you must multiply the top as well. Once you have that, I cross multiply to get rid of the fractions. And in this class, fractions and decimals both are good answers. It's up to you to decide when it's appropriate to use which one. Now, here's a tougher example using the same idea, but now we're going to include a little bit more algebra in this problem. This would be a good one to pause once you see the equation and work on trying this one first. So the tougher part, obviously, is trying to figure out what is the common denominator. Pretty easy in the first problem to figure out the common denominator was 6. In this one, it's going to test your algebra skills a little bit in order to figure that out. You can always just multiply the 3 things together on the bottom to get your common denominator, or however many denominators that you have, you can multiply them together. Or hopefully in this case you recognize that those first 2, x minus 2 and x plus 2, multiply together to give you that last x squared minus 4. So in this problem, x squared minus 4 is the common denominator. That's your common denominator. You're going to write down the bottom of each of your three fractions. And then remember, whatever you multiply the bottom of, you must multiply the top. So in that first term, I'm multiplying the bottom by x plus 2, so I must do the same on the top. In the second one, I'm multiplying the bottom by x minus 2, so I have to make sure I multiply the 3 by x minus 2 as well. I already have the x squared minus 4 in that last term, so that's why the top stays the same. Once you have common denominators there, really you can get rid of those because it's just you solving the tops of those, the numerators, in order to figure out what the answer is going to be for x. Very important here as we get to the end of this problem. X equals negative 2 appears to be the solution to the problem, but as you always should do with algebra problems, when I take that negative 2 and I plug it back in to the problem, you'll notice that in that second fraction it becomes 3 over 0. You should remember that you can never have 0 as a denominator. If you don't know the reason for that, make sure you ask. I can explain it to you later on. But because we can't have 0 as a denominator, then the answer to this problem is no solution. We refer to x equals negative 2 as an extraneous solution. That means one that we're able to get algebraically, but does not actually make the original equation true. We'll see this quite a bit as we go through this year in calculus. Important thing to remember, always check your solutions. Just make sure they work. So try some of those problems in your homework tomorrow, or in our practice time in class tomorrow. Make sure that you understand how to find those common denominators and how to look for those extraneous solutions as well. Alright, switching gears a little bit here. Our third practice problem is just a quadratic equation. I do like using FOIL, or unfoiling it in this case. Remember, we're looking for factor pairs of -6 that when you add them together are going to give you -1 in this case, the number that's in front of that middle term. And remember, with these you can always use a quadratic formula, so if you're not very good at FOIL or if you just don't want to think that hard, you can always do that. I know many of you have the quadratic equation on your calculator. Please be careful about relying on that. There will be times that I'm going to want an exact answer in some problems like this, and your quadratic equation formula program will not work, will not be very helpful for that. Here's another example of a quadratic equation. Now, if you remember earlier, I mentioned that anytime that you introduce the square root symbol into the problem itself, it's going to yield you two answers. It's going to yield you a positive and a negative answer. So when you do this problem, you don't just get x plus 3 equals 4, but you get x plus 3 equals 4 or x plus 3 equals -4. Very common mistake to forget to do that. So make sure you remind yourself, when I introduce the square root symbol myself, it's always going to come with a plus or minus on the opposite side. And now at this point you can go ahead and solve for each of those equations, and you get your two solutions, 1 and -7. Again, does not hurt to check those answers out. Make sure that they really do work in this problem. Just a reminder, when you check your work, you always want to check your work back into the original problem before you've done any manipulation of it. The last quadratic equation we'll look at can be solved a variety of ways. Some of you may remember when your Algebra 1 or Algebra 2 teacher taught you how to complete the square. I'm not going to go over that right now. If you like that method and you remember that method well, feel free to do that. It is a quick way to solve the problem. It does have its uses, especially if we were graphing a quadratic equation and we wanted to find the vertex point of it. But for now, I'm just going to use this example to help reinforce or refresh your memory of the quadratic formula. Please take a moment to write that formula down, if for no other reason, to help you remember what it looks like. Remember, that's negative b, or the opposite of b, plus or minus the square root of b squared minus 4ac, all of that over 2a. Remember, the a, b, and c refer to the coefficients that you can find in front of the terms in a quadratic equation when they are in the proper order. Since there wasn't a 1 in front of the x squared in this problem, we'll write that in. That becomes our a. Positive 6 is our b. And remember, the negative 5, the whole thing, the negative included, is our c. I do like to write a lot of those into my problems. I do my work. Helps me to avoid some careless mistakes. And again, I know a lot of you have this formula or this program on your calculator, but I would recommend that you know how to do this work by hand as well. Again, there will be times that you will not be able to just plug it in and get an exact answer, or whatever it is I'm looking for in a problem like that, as we start dealing with perhaps imaginary numbers and things like that. A problem like this is perfectly acceptable to go ahead and approximate and give decimal answers for this. In this class, for the remainder of the class, typically 2 decimal places will be acceptable when you're rounding. Again, I'm more concerned about the method that you use, not just the answers to the problem. Last few example problems here are going to start combining ideas together. Again, it'd be good for you to attempt to do some of these on your own, not just watch. Question like this, a polynomial equation. You'll notice that I'm not canceling those x's out. I'm not dividing both sides by x squared. You need to be careful of doing that, or you may lose a solution. What I mean by that is, when you get to the end of this example here, you might notice that if you would have divided both sides by x squared way back in the beginning of this problem, you would lose the solution x equals 0 in this problem. So it's much better to factor here and pull your x squared out, as in the distributive property, than to try to cancel that and lose those answers. Next example we're going to look at is going to use a fractional exponent. Probably do not have a lot of experience with this. When dealing with a fractional exponent, you need to kind of remember what you do when you're using whole number exponents. If you want to undo squaring, you take the square root. Well, the square root is the 1/2 power. If you want to undo cubing, you take the cube root, which is the 1/3 power. So in this problem, since we want to undo the 3/2 power, again, we'll take the reciprocal of that, which is the 2/3 power. 2/3 will undo the 3/2. So if I take the 2/3 power on each side, it cancels my exponents out on the left, leaves me x. But on the right side, it'll be 2 to the 2/3 power. you'll see that you can rewrite 2/3 power as 2 squared with the cube root of all of that. So one possible answer here would just be the cube root of 4. That's an exact answer. Or the approximate answer to that is acceptable as well. Here's an example problem where we're using a radical, so a radical equation. Important to remember that when you solve this radical equation, many of you know, yeah, I'm going to square both sides in order to get rid of that radical, but you don't want to do that until you get everything away from that square root that's not under the square root. So you'll notice I added that x to the other side first. You notice that I'm taking a moment to emphasize the importance of how do you square a binomial like that. It's very frustrating when all people do is just square the x and square the 2 and say the answer is x squared plus 4. But remember, when you do this, this is really a FOIL problem. If you have to write it out, please do. But remember, when you square that, you are going to get 3 terms there. People commonly forget the plus 4x term. Going back to the problem now, you'll see we have 2x plus 7 equals the x squared plus 4x plus 4. And at this point, you're solving this just like any other quadratic. I'm choosing to take it over to the right side this time simply because I do not like a negative x squared. You could use quadratic formula here if you like, but I can recognize that this problem does factor using the FOIL method, and I get my 2 solutions here. Again, as you do these problems, whether it's on a quiz or a test, be sure to check those answers out. Make sure you get the correct answers at the end. Last example problem we'll look at here is an absolute value equation. Remember, I mentioned earlier in the video, anytime you're using an absolute value equation, you're going to split that equation into 2 parts. First part looks exactly like the original equation was written, but without the absolute value signs. The second one, we're going to take the opposite of what's in the absolute value symbols. Now, I would very much encourage you to put that in parentheses so you be sure that your negative sign gets carried through that whole expression there, and then set that equal to the opposite side of the other side of the equation as well. Once you have that, it's really just 2 equations that you're solving separately from each other. But you'll notice as you go through this process that you now have the potential for a lot of values that will make this equation true. In this case, we have a potential of up to 4 different numbers making this problem true. Again, I really would recommend that you check those answers into your problem. I know it will take you a few moments to do so, but you'll know as you walk away from this question whether or not you have it right, and the confidence that you get from knowing that on that quiz or test. I hope these 9 example problems give you just a little feel, a little taste for what I would recommend you be able to do as a student that's done with Algebra 2 and moving into Trig and Calc. These are all things that you should be very comfortable with. If you're not, that's okay. You just got to make sure that you use the class time to practice these to get them figured out. You'll have many problems to choose from to work on your skills with this. I would recommend that you use that time wisely to work on those problems that you find most challenging, most difficult, before we take a quiz on it. So remember the 7 types of equations that you are responsible for: identities, conditional equations, linear equations, quadratic equations, polynomial equations, radical equations, and absolute value equations. We'll see each of those throughout this school year, so make sure that you know those well. And I hope that you're familiar with these methods for solving them. See you next time.